Sci-fi movies are sometimes criticized when explosion in the void make noise. As the old saying goes, in space no one can hear you scream. Without air, there is no sound. But if that's true, what was the space physicist Don Gurnett talking about last month? When he stated at NASA's press conference that he had heard the sound of interstellar space. It turns out that space can make music if you know how to listen. Gurnett is the James Van Allen Professor of Physics at the University of Iowa and the principal investigator for the Plasma Wave Science Instrument on Voyager 1. At the press conference, he played some plasma wave data for the audience. The sounds he explained were the sole evidence that the Voyager 1 had left the heliosphere. The heliosphere is a vast bubble of magnetism that surrounds the Sun and the planets. It is essentially the Sun's magnetic field inflated to enormous proportion by the solar wind. Inside the heliosphere is home. Outside lies interstellar space, the realm of the stars. For decades, the researchers have been on the edge of their seats, waiting for the Voyager probe to leave. Ironically, it took almost a year for NASA to realize the breakthrough had occurred. The reason is due to the slow cadence of transmission from that distant spacecraft. Data stored on old-fashioned tape recorders are played back at 3 to 6 months interval. Then it takes more time to process the readings. Gurnett recalled the thrill of discovery when some month-old data from the plasma wave instrument reached his desk in the summer of 2013. The distant tones were conclusive. The Voyager 1 had made the crossing. Strictly speaking, the plasma wave instrument does not detect sound. Instead, it senses waves excited by the electrons in the ionized gas or plasma that the Voyager traveled through. No human ear could hear these plasma waves. Nevertheless, because they occur at audio frequencies between few hundred and few thousand hertz, we can play the data through the loudspeaker and listen, says Gurnett. The pitch and the frequency tell us about the density of gas surrounding the spacecraft. When Voyager 1 was inside the heliosphere, the tones were low, around 300 Hz, typical of plasma wave coursing through the rarefied solar wind. Outside, the frequency jumped to a higher pitch between 2 and 3 kHz, causing to a denser gas in the interstellar medium. That transition was music to the Gurnett's ear. So far, the Voyager 1 had recorded 2 outbursts of interstellar plasma music, one in October to November 2012 and a second in April to May 2013. Both were excited by the burst of solar activity. We need solar events to trigger the plasma oscillation, says Gurnett. The key players are CMEs, hot cloud of gas that blast into the space when solar magnetic field erupts. A typical CME takes 2 or 3 days to reach Earth and a full year or more to reach Voyager. When the effects of a CME passes through a plasma, they excite oscillation akin to the fingers strumming the strings on a guitar. Voyager's plasma wave instrument listens and learns. We are in totally unexplored region of space, says Gurnett. I expect some surprise out there. In particular, the Gurnett is hoping for the plasma wave not excited by the solar storms. He speculates that the shock fronts from the outside the solar system could be rippling through the interstellar medium. If so, they would excite new plasma wave that Voyager 1 will encounter as it plunges even deeper into the realm of the stars. The next sound from out there could be surprising indeed.
Want to join us on our journey to the greatest mysteries and sensational discoveries? Then subscribe to Bright Kerlite English and never miss any of our videos in the future. Remember to give our posters a thumbs up to show us that we keep you engaged with our content.